Let's start with the problem. Maximum sum subarray array index. We are just like keeping the count, not actually the count, but the sum. We are keep and all of the possibilities are done. We can return the result from here. Now this approach, although it is right, but it takes a lot of time. You can see that your I is going to run for n times, and for every time your j is also going to run for n times. Not even from I till j, not even from I till n minus 1. It is going to go for I till the next approach 2. One thing I would want to tell you is, like, we have two situations. First of all, that we can find up our maximum subarray in the normal situation, or we may find our maximum subarray in the circular situation. Both are the possibilities. So why not, like, we already know how to calculate the normal maximum subarray, right? Basic Cadane's algorithm. Let me give you a little revision of that. What do we do in that? We iterate through all the elements. My I just travels from the beginning, 0th element to the first element, considering how we are forming up our loop. Okay, so here what are we going to do? We are going to have a result variable, and we will have one sum. So every time we are going to calculate the sum, we are going to maximize the result. How? Let's see. Let's suppose I have this element I. Now initially, I would have included that in my sum because I'm considering the first element. that is going to be the minimum, like this one element is going to be the minimum possibility of your subarray, right? Then you keep on adding the elements, right? And every time you see whether the sum you are adding up, that means your sum plus ARRI, if this is giving you the bigger value, that means if this value is included in the sum, if this is the bigger value, or this value independently is the bigger value. Okay, we are considering all the elements ending with our ith value. Okay, if that is bigger, then we consider that, or we consider the ith value only and we proceed a new subarray with it. Okay, this is how we do it, correct? So once we are done with that, we know that we can easily calculate our normal subarray sum. Now the thing is, how are we going to calculate the circular subarray sum? For that, you might already be aware about prefix and suffix, right? In which we consider some trick, or you can say some step that we will follow for all the prefix subarrays or for all the suffix subarrays. So in this, what I will do is, let's name this array as maximum suffix and start calculating the suffix. Okay, here. So the last value will be copied, right? This one is negative. And now what are we going to do is, we are going to check that, okay, what is the summation here? Well, here 12 plus minus 11, it will be 1. Now what is bigger? 1 is bigger or 12 is bigger? The value already. Okay, 12 is bigger, 12 will be kept here. Now moving ahead in the same direction, I have 1. So 1 plus 10, it will turn out to be 11. So what is bigger, 11 or 12? 12 is bigger, 12 would be kept. What is this signifying actually? Well, it is saying that from this point onwards, which subarray would you choose which would have a maximum sum? So for every turn, if you're going to choose this one, or this one, this 12, the value 12 that you have, the sum that you have, is going to be the maximum. Okay, so let's keep on making our suffix array. So far the value was 11, so 11, negative 9. Now what do we have? We have 2 here. Which is bigger, 2 or 12? 12 is bigger, 12 would be written here. Again, coming here, I have 9 plus 2, that would turn out to be 11. Which value is bigger, 11 or 12? 12 is still bigger, we are going to keep on considering this value. Then I have 11 and negative 8, we would have 3. Now here, 3 or 12, which is bigger? Obviously, 12 is bigger, so 12 would be kept here as well. Now, again adding up this value, 8, 9, 10, 11, we would have 11, and 11 and 12 is still 12 is bigger. In this particular case, we started with 12 and that value didn't change because that was the maximum one. But there could be a scenario that you encounter a bigger value here. Assume if here, like instead of 8, or let me change any value in middle and tell you. Let's suppose instead of this negative 9, we had plus 9. Then it would be 11 plus 9. It would go to 20. Now, what will be the bigger value? 20 or 12? Then it would have been 12. So we would say that from this point onwards, if you have to choose a maximum subarray that includes that is valid from this point till the end, you can choose this array. Okay, this array including all of these values because its value is bigger than any so far. Now that we have understood that, let's keep on sticking to the example that we have of negative 9. It will be 2. Now that we have made a suffix, it is telling that in this direction, in the suffix direction, what is the maximum sum subarray that we have. We have to do the same thing for prefixes. Now, once we have the suffix and once we have the prefix, at every ith possibility, I'm taking the maximum prefix and the maximum suffix. I can add just both of these and I would get the circular subarray. Let's see how are we doing that. Let's just start considering this element and start calculating the prefixes. Okay, let me raise up all of these values. The work of suffix is done. Now we are going to take help of this suffix, the maximum suffix array. Let's just start calculating. So initially I have 8. Okay, so far if we consider this subarray, I have this prefix sum as 8. What is the suffix sum? If we consider from here, what could be the maximum sum subarray possible in this direction, in the suffix direction? Well, we have to check the I plus 1f value, this one. So for here we have 12. So we can only take this possibility if we are going for maximum. Alright, now that we have done that, let's see what will we get here. Well, for us, if we consider this possibility, we would have 8 plus 12. That means we would have 20. Let's call it as circular result. Okay, we have calculated it as 20. Now I'm going to see every possibility with prefix and suffix, and here I will check that if I get any bigger value than 20, I would replace it simply. Now let's just start growing our prefix. Now here it would be 8 and negative 8. That means 0. If you're considering the array so far, then the prefix would be 0, but the next suffix would be 12, maximum suffix that we can consider. So it would be 0 plus 12. Again, it is not going to change because 12 is less than 20. No worries. Let's include one more value. We included 9, 0 plus 9. Now I have the prefix as 9 and the suffix as 12. 9 plus 12. What happened here? We got a value which is bigger than this. We got 21. So now this is going to be overwritten. Again, continuing the situation, 9 and negative 9, we got 0. 0 plus 12, this is the ith value. Checking the ith prefix and I plus 1th maximum suffix that we have stored. Okay, do we get any value? We don't. Because we get 12, but that is not bigger than 12, than 21. Then going to here, at 10. Now if I do 10 plus this value, 12, I get 22, which is bigger than this one. I would replace it. And then I would again include -1 and this -11, which would make my prefix -1. Now my answer is -1 plus 12, resulting in 11. It is not bigger than that. So this is going to be predominantly considered. Here, once I'm done with it, okay, let's take this value. Here, if I calculate the prefix, I can say -1 and 12. I only got 11 again, right? So we are not going to consider that because the prefix, like this complete array, is not giving you the maximum, correct? So from the circular response, or you can say from the circular result, we have got the maximum to be 12, in which we were considering this array here till 10, and the last value was being included in this manner. And let's take a closer look at this example again. Here we can get this array in these many, including this 12. I actually kind of missed it, right? But this was here. That means we are considering the circular fashion in the first one as well. I think I'd like to think that I've missed it previously, but now you know that 12 is also written here, correct? So this is a circular subarray which is leading us to the maximum value. Now in this case, you can see, you can find out the circular subarray, you can find out the normal maximum subarray too. But what will happen eventually once you are done calculating both of those, you just need to see which is the maximum. Is the normal maximum or is the circular result maximum? You will keep the maximum of both and then you can return that as the answer. Okay, quite simple. Let's try to analyze the complexity of it. What are we doing? First of all, we are moving in two directions. First one is this, left to right. Another one is this, right to left. First of all, we calculated the suffix. For that, we took order of n. Then after that, we calculated the prefix. For that, we took order of n. Just in the same same loop, I can also perform my normal cadence algorithm because I do have to keep track of that, right? So in this order of n only, this normal cadence would also be included because we are traveling in the same direction. And once that is done, we can eventually say we are not taking any time more than order of n. But are we taking any extra space here? So this time we are. We are taking this maximum suffix array. Thus, the space complexity is also going to be order of n this time. Let's see the code for the same. So here, I have this variable n, keeping the track of the length of my array. Then I have made this suffix sum, initializing with the last value, as I've already told you in the diagram. Then I would have this array made of maximum suffix, which would be initially marked as zeros all, like this. And the last value will be copied, the way I copied 12. And then what are we doing using this loop? We are calculating the suffix sum and we are keeping the maximum value that has occurred so far. See, we are keeping on our suffix sum and we are only keeping the maximum value of these two. Either the suffix sum which has been calculated or the previous value that I have. For this ith value, I have to judge whether the suffix sum that I've calculated is that bigger or the I plus 1th value that I have here is that is bigger. In our case, we knew we had 12 copied because this value was -11 and it was giving us 1 as the answer. Okay, so we only kept this maximum value. And we have to keep on filling our suffix sum array. We have seen in the diagram how we do that. And this loop will be responsible for that. One part of the question is done. That means we have calculated the suffix. Now we have to move ahead to the prefix. Here I have circular sum that I have created. This will be keeping the track of my circular sum. And then I have also created a variable normal sum. Okay, we will take help of